Mr. Barry here again, talking to you about absolute value functions, and we're just using the picture and using the fact that we have this common equation that we can always use in order to break down and gather up an equation from the picture. A lot of labeling to the picture and making sure that we know important spots on the picture. We always start off the most important spot with the vertex, so I'm going to go ahead and find the vertex. This graph is a little bit different from what we've seen before because it looked as if the V is now upside down. But let's go ahead and find out the vertex regardless. I'm going to go over to the left now. 1, 2, 3, 4, 5, 6. And go up 1, 2, 3, 4, 5. So I went left to the 6. And then I went up 5. So the vertex here would be the point -6, 5. We know that as a point, it's x comma y, but here for us in the absolute value functions, that we're really looking at it as h comma k. So I'm going to go ahead and throw an h comma k over top of it. We'll come back to it later. That vertex also gives me a couple other things. We can go ahead and say that we know the axis of symmetry here. The axis of symmetry goes as a vertical line right through that vertex. Our vertex here, that vertical line would be x is equal to -6. And we use that vertical line, that mirror, to figure out what the slope is off to the right side of the mirror. So again, not really concerned too much about the left side. I'm going to use the right side to mirror that. I'm going to go ahead and count this out. Now remember, we do rise over run for slope. But in this case, we're actually not going to rise. We're going to go fall a little bit here. So I'm starting at my vertex, and I go down. 1, 2, 3, and over to the right 1. And I continue that pattern. 1, 2, 3, and to the right 1. So here, I'm going to kind of draw a little bit of an arrow there just because I don't have a lot of room to write. For the slope, I've gone down 3 and to the right 1. The word down in math means negative. The word right means positive. So I'm really looking at -3 over +1, which we can simplify as -3. It's significant because not only is that our slope, but we know for an equation, the letter A comes from that information as well. So we know that A is equal to -3. I'm going to plug all that information in. The one place I'm really concerned about with that is the letter H. And this is a perfect example why. I'm going to use a little bit less parentheses, but I'm going to take my time to write this out. I presume that it would be a great idea for you to write it out also. Our A value here is -3, so now we finally have something over here that doesn't involve the number 1. The absolute value of x, and there's the trick. I got a minus sign as part of the formula, then I have a -6 that's going to go right behind it. So I'm going to go ahead and write that out right now. And I'm going off the board here, which is fantastic, but that's okay. Hopefully that fits in the screen. It does. We got it all right. And I can't stress this enough or say this enough. We got to be careful at that letter H. We got to be careful at that letter H because now I have a minus negative, and hopefully we all understand that minus negative for us in math means that we're going to go ahead and make that a plus sign. So if I'm wrapping this up, I have the -3 on the outside. I got the x minus negative makes +6, and then +5 at the end. This right here would be my equation for this particular picture right there. I've written a lot. I could write some more. Some of the things that I want to check out is when I'm comparing it to my parent function. So again, as I take a look from here to here, the most obvious thing that we've talked about here is that the graph has flipped and the V is now going downwards. The main culprit to that is our letter A. That letter A is now negative. The graph is now going downwards. So one of the big things that we could talk about here in comparing the graphs is that we're now pointing downwards. The graph is opening up downwards. Some of the other things to mention here is let's go ahead and take a look at the vertex and how that's changed. Here it was at 0, 0. There it's at negative 6, 5. So the whole graph has moved off to the left and upwards. The whole graph has moved up to the left and upwards. The whole graph has moved left and upwards. Now that the graph is pointing down, we know that this point right here is actually not a minimum. Before it was a minimum, now it's a maximum. I can go ahead and label that if I wanted to, that this is now a maximum. And finally, and this might not be as clear as what it could be, but this graph right here has the a value of 1. This graph right here has an a value equal to negative 3. And this, compared to what's happening over there, the graph and the absolute value, generally speaking, has become skinnier. So the width of the absolute value is now skinnier. The width of the absolute value is skinnier. Again, a huge amount of information from one picture here in particular, but we're giving it over to you, and hopefully you're starting to see a pattern that will continue in the next video.